Hello everyone, welcome to my channel. In this video, we will begin learning about quadratic equations, an important topic in mathematics and also for exams like IIT JEE. We'll go step by step, starting from what a quadratic equation means, how to form it, and later how to solve it using different methods. So, without any delay, let's get started. A quadratic equation is simply an equation where the highest power of the variable is 2. The general form is ax square plus bx plus c. This is a quadratic polynomial of the form ax square plus bx plus c, and we should make sure that a is not equal to 0. A quadratic equation in the variable x is an equation of the form ax square plus bx plus c is equal to 0, where a, b and c are real numbers. Okay, for example, 2x square plus x minus 300 is equal to 0 is a quadratic equation. In fact, any equation of the form p of x is equal to 0, where p of x is a polynomial of degree 2, is a quadratic equation. Why is it that a is not equal to 0 in quadratic equation ax square plus bx plus c is equal to 0? If ax square is equal to 0, then only that is remained here is the linear expression. Then we will get linear equation, not the quadratic equation. It is always important to have a degree 2 if it is a quadratic equation. Okay. And one more thing is, there are two conditions for this quadratic equation. What are these? A is greater than 0 or a is less than 0. So if f of x is equal to ax square plus bx plus c, this is a quadratic equation and this is quadratic expression. This is called quadratic expression. Okay. And for quadratic equations, if this is the x-axis, the roots will be like this, either like this or here. This can be alpha and this can be beta, or this can be gamma, or this can be delta. How are these possible? This is possible when a is greater than 0, and this is possible when a is less than 0. You will come to know about this as we move forward. We have seen roots of quadratic equation. So if we take an example like x square minus 2x plus 1 is equal to 0, and by factorization method we'll get x minus 1 whole square is equal to 0. The factors that we obtain are x is equal to 1 and 1. These are two different roots that we got from this quadratic expression. These are two different roots, but these are same, right? That means they are real and equal. And if we observe, we are getting two roots, right? Why are we getting two roots? Because ax square plus bx plus c, here the highest power we have is 2. That's why we are getting two roots. But in case x to the power of 10 minus 5x plus 15, sorry, plus 5x plus 15 is equal to 0, then based on the power here, we'll get 10 roots. So the highest power here is 10, so we'll get 10 roots. So if it is x to the power of n polynomial, then we will get n number of roots. Some quadratic equation. For example, if we take x square plus x minus 6 is equal to 0, what are the possibilities of roots here? here it is minus 6, right? So minus 6 is equal to minus 6 into 1, and minus 6 is equal to minus 1 into 6, and we'll get minus 6 from minus 2 into 3, and we'll also get minus 6 from 2 into minus 3. So these are all the possibilities we have. But how do we actually get this? X square plus minus 2x plus 3x minus 6 is equal to 0, right? X into x minus 2 plus 3 into x minus 2 is equal to 0. X plus 3 into x minus 2 is equal to 0. Finally, we'll get x is equal to minus 3 and 2. These are rational integers. These are we can do this method for rational numbers and integers. We also have another method of obtaining roots from quadratic equations. Now we'll look at how we'll obtain roots from quadratic equation. The formula is, that method is formula method. The formula for that is x is equal to minus b plus or minus root of b square minus 4ac by 2a. This is the most important formula. Okay, here b is the discriminant, b square minus 4ac. This is the discriminant. Discriminant is the one that decides which type of root it is, whether it is real, complex, or equal. If d is equal to 0, then we'll get equal roots. And if d is equal to minus, we will get complex roots. And if d is positive, d is negative, and if number, then we'll get real roots. Equal roots, complex, and real. Mostly, if a question is given and we are to find irrational or complex numbers, we can use this formula method. X is equal to minus b plus or minus root of b square minus 4ac by 2a. Okay. In case only roots are given, in case only roots are given, how do we find the equation? Let's say the root, we are to find an equation from it. We can directly substitute the given roots in this equation. Now we'll try to understand nature of the roots. If a quadratic equation ax square plus bx plus c is equal to 0 is given, and x is equal to the roots alpha and beta, we can simply write them as a into x minus alpha and x minus beta is equal to 0. It is always important to place a, because we have to know whether it is a positive we have to always keep this a in order to know whether the curve is in positive or negative on the x-axis. It indicates whether it is up or down graph. For the equation ax square plus bx plus c is equal to 0, a is very important. It helps us understand whether the curve is up or down. that means whether the curve is up or the curve is down. And D says whether the roots are real or distinct, real and distinct, or real and equal, real and equal. And it also says whether the roots are complex, imaginary. Okay, and for this D is greater than or equal to 0, and for this D is equal to 0, and for complex it is D is less than 0. It's not just or, we can say real and distinct. D is greater than 0. Real and equal, D is equal to 0. For complex, D is less than 0. Now we'll understand this determinant clearly. For D is greater than 0, x is equal to minus b plus root d by 2a, and minus b minus root d by 2a. Here the roots are real and distinct. And for d is equal to 0, x is equal to minus b plus or minus 0 by 2a. Okay, and minus b plus or minus 0 by 2a. Here both the roots are same. So here the roots are real and same. In case of d is less than 0, we'll show it with an example here. If x is equal to minus b plus or minus root minus 9, okay, by 2a. Okay, here the roots are complex. Nature of roots, if a is greater than 0 and here a is less than 0, we have different possibilities. With d is equal to 0, we have the curve this way. Here we'll get alpha and here we'll get beta. And if d is equal to 0, both alpha and beta will be at one single point, alpha, beta. And if d is less than 0, we'll have the curve like this. The curve doesn't touch x-axis when f of x is greater than 0 and f of x is greater than 0. Here, if this is when the roots are real, and when it is complex, d is greater than 0 and alpha and beta, and d is equal to 0, then the alpha and beta will again be at the same point but in the downward curve. When d is less than 0, the alpha and beta are again the downward curve, but it again doesn't touch x-axis. Here, alpha, beta, alpha and beta. Okay. This is the nature of the these are the graphs for the nature of the roots when a is greater than 0 and when a is less than 0. These are the graphs when the nature of roots are greater than 0 and the roots are less than 0. When the determinant is greater than 0, we'll have the curve like this with the roots are real and distinct. And when d is equal to 0, the roots are real and equal. And when the determinant is less than 0, the roots doesn't touch the x-axis. They are real and distinct, but also doesn't touch the x-axis. Likewise, for imaginary case also, if d is greater than 0, the curve is downwards and the roots are distinct, complex and distinct. And with d is equal to 0, it is the roots are on the same place, and with b is less than 0, the roots again doesn't touch the x-axis. Relation between coefficient and roots. The expression ax square plus bx plus c is equal to 0, where a is not equal to 0 and a, b and c are real numbers, the quadratic equation with real coefficients, and the roots are alpha and beta, the sum of the roots alpha plus beta is equal to minus b by a, and the product of roots is alpha beta is equal to c by a. This is very important formula, and many questions have been asked with these formulas. Another important topic is common roots. Roots is if the equations a1x square plus b1x plus c is equal to 0 and a2x square plus b2x plus c2 is equal to 0, and if the roots are alpha, beta, and the roots are gamma and delta, and if the roots are alpha, beta, and here if the roots are beta and gamma, and here if the roots are alpha and beta, and here also if the roots are alpha and beta, then if you observe the condition, no roots are common here. No roots are common. And here only one is common. Only one. And here again both are same. Both are common. In that situation, with no common roots, no condition is applicable. But if there is any common root, like if there is any common root, then the condition is a1 b2 minus b1 a2 into b1 c1 c2 minus c1 b2 is equal to c1 a2 minus c2 a1. Okay, with one common root, this is the condition. And if there are two common roots, then a1 by a2 is equal to b1 by b2 is equal to c1 by c2 is the condition. Okay,